Welcome back. It's been a while since I've seen you all, so to speak, in a tutorial. So we're starting out with our first Chapter 10 tutorial, Quantities in Chemistry, and this is all about the mole. And the mole is equal to 6.02 times 10 to the 23rd. Let me get this out of the way. Go away there. Go away. Thank you. 10 to the 23rd particles of a substance. All right, and I really need to put the qualifier in here, representative particles of a substance. And it's important that you understand this concept of a representative particle. So over here on the left-hand side, we're going to make a little chart in order for you to understand that. So here on the one column, I will list the type of substance, and RP is going to stand for representative particles. So let's say I have something like Cl, which, as you know, is the element. It's an element, chlorine. The representative particle of any element would be an atom. The smallest particle of that particular substance is what we're talking about. If I have Cl2, pure chlorine gas, this is no longer an element. It is a molecule. As you recall, Cl2 is a diatomic molecule. So the representative particle, the smallest particle of that substance, is a molecule. Water, a very common substance. This is a molecular compound made of all nonmetals. Therefore, it's molecular. The representative particle is a molecule again. Sodium chloride. This is an ionic compound. Metal plus nonmetal, remember, is an ionic compound. The representative particle of an ionic compound is a formula unit, not a molecule. I'm not going to take the time to explain the difference between the two right now, but remember that it's a formula unit. If we have just sodium Na+, the representative particle is an ion. That's the smallest unit. So if we keep these in mind, and by the way, these details are outlined in a chart on page 290 of your textbook, and you can see some more examples of this. This is going to be really important as we work through and understand quantities in chemistry. So what we're going to do is work on a couple of problems, all right? And we often measure substances in moles in chemistry. And as we get along here with these problems, you'll understand a little bit more why we do that. But let's say we start out with 1.14 moles of SO3, sulfur dioxide, okay? I want to know how many molecules do we have? Well, what I do in order to figure this out is use a conversion factor. And a conversion factor is a fraction, and we often put it inside parentheses. So I'm going to label this conversion factor to make that very clear to you. You're going to be using a lot of them in the next couple of chapters. Now, one thing to keep in mind about the conversion factor is that in the numerator, on the top, this is the units we're converting to. And in the denominator, on the bottom, these are the units we're converting from. So now we can fill in the necessary information in that conversion factor. I want to convert 2 molecules. That's what's being asked for here. So molecules is going to go on the top. Unfortunately, there is no abbreviation for molecules, even though it's kind of a long word. So we just have to put up with that. We are converting from moles, so moles goes on the bottom. And by the way, the abbreviation in chemistry for mole is MOL. We dropped the E. Granted, it's not much of an abbreviation, but that's what it is. So, from our knowledge of the mole, there are 6.02 times 10 to the 23rd molecules in 1 mole of any substance. Okay? So this ends up being a multiplication problem. Okay? So we have moles of this substance, okay? And we want to convert to molecules, so we're multiplying 1.14 times 6.02 times 10 to the 23rd. So I'm going to get out my handy dandy calculator because I didn't do this ahead of time. And by the way, make sure you can enter scientific notation correctly on your calculators. That's going to be key here. And what we get is 6.86 times 10 to the 23rd molecules of SO3. In your answer, you always want to have units with the substance. A number without units is meaningless. I also want you to put a nice, neat box around your answer to distinguish it from your work. By the way, when you're showing work for me in class, you must show your work exactly as you see it here. So get used to doing it in this format. I know that you can do it in some other ways and take some shortcuts. That's great. Give yourself a pat on the back. But when you show your work for me, this is what I want to see with units and everything. Okay? Let's look at another problem. Let's say I have, I'm going to use this same number to start out with, 1.14 moles of SO3. And I want to know how many atoms are in SO3. Now, when we look back at this chart, and we can see that any molecular compound, the representative particle is a molecule, not an atom. So what that means is we cannot convert directly to atoms from moles of SO3 in one step. We need 2 steps. We need our first step, we need to convert to representative particles, which is molecules first. Okay? So we know that there are 6.02 times 10 to the 23rd molecules in 1 mole. Then we can convert to atoms. So atoms will go on the top of our next conversion factor because that's what we want as our answer. Remember, it goes in the numerator. And we want molecules to cancel out, so molecules goes in the denominator. All right, and actually it's better here if I write atoms, molecule, 1 molecule here. How many atoms are in a molecule? Well, this is specific to the compound in the question, sulfur trioxide. There are 3 atoms of oxygen and 1 atom of sulfur for a total of 4 atoms in a molecule of sulfur trioxide. So we end up multiplying 1.14 times 6.02 times 10 to the 23rd times 4. Now remember that multiplication is communicative, so commutative. You can correct me on which term that is there, but basically what this means is it doesn't matter the order in which you multiply. So it might be even more helpful to say 1.14 times 4 times 6.02 times 10 to the 23rd. And when you look at that, you can see that your answer should be greater than 6.02 times 10 to the 23rd. And as an aside, it's going to be very important to really analyze your answer and say, how big or how small should my answer be? Does it make sense? So when we do all this math, we end up with 2.75 times 10 to the 24th atoms. And so we can see that this answer is indeed bigger than 6.02 times 10 to the 23rd. Okay, we have a higher exponent here. Now, a little digression here. This number, let me put it in a nice little green cloud here. It's my favorite color. This is known as Avogadro's number. And in class, I described and explain that a little bit further, and I won't take the time to do that here. But if I refer to Avogadro's number, you always should in your head be thinking 6.02 times 10 to the 23rd. Here's another problem we can work on. Let's say that I have, 2.80 times 10 to the 24th, times 10 to the 24th atoms of silicon. I want to know how many moles is that? Okay? And you might be thinking to yourself, well, who cares? Why do I need to know how many moles? Well, trust me, being able to measure substances in moles is going to be very helpful in the laboratory. Okay, so right now we're talking about the theoretical aspect of this and giving you a little bit of theoretical problem-solving background. In the next couple of classes, we will start moving into more practical applications. So the substance that we're working with is silicon. This is an element, so the representative particle is indeed an atom. We need to convert to moles. So since we are in representative particles already, we can go directly to moles. So 1 mole is going to go on the top. This is the unit we're converting to. What goes on the bottom? Atoms, because we want to get rid of that unit. There are 6.02 times 10 to the 23rd atoms in a mole of any element. This time, this is a division problem. Anytime you multiply by 1 over something, by the reciprocal, you are dividing. So you are taking 2.80 times 10 to the 24th divided by 6.02 times 10 to the 23rd. Now, as an aside, like I said, it's often good to analyze and say how big or small should my number be. And we can do some really neat little estimation right now. 2.80 times 10 to the 24th is also equal to 28 times 10 to the 23rd if I put it in the same exponent form as Avogadro's number. And then if I'm dividing by 6.02 times 10 to the 23rd, which is about 6 times 10 to the 23rd, I'm going to end up with an answer that is between, we think about it, 6 times 4 is 24, 6 times 5 is 30, so our answer should be between 4 and 5. And since 28 is closer to 30, it's going to be closer to the number 5 than the number 4. So we should get something like that as our multiplier of our answer. Okay. Now let's go back and do the actual division. We end up with 4.65 moles of silicon, and I can see that, yes, my answer is between 4 and 5 and closer to the number 5. Being able to estimate your answer is a valuable skill to ward off any number punching errors in your calculator. One of the biggest problems I see is students punching numbers wrong in their calculator, coming up with this wildly incorrect answer, innocently writing it down without any thought, and getting the whole problem incorrect. So I'm warning you now about that. Okay? How about we do one more problem? I got a little bit of room in here. I'm going to squeeze this in right down here on the bottom. Okay, so let's say I have let me think. Okay, wheels are turning in my head. If I have 1.00 times 10 to the 25th. Atoms of sodium. How many moles do we have? Okay, So when I set up my conversion problem, and pardon me, squishing this all together, let me go back, put a little box around that to separate it. So we're going to squish this in here, but I think you can handle that. We're converting to moles. 1 mole goes on the top, and there are 6.02 times 10 to the 23rd atoms in a mole. So again, we're dividing because we're multiplying by 1 over something. So 1 times 10 to the 25th divided by 6.02 times 10 to the 23rd equals, let me try this again, 1.66 times 10 to the first power. Okay. And my units are moles of sodium. Okay. So these are some just very basic calculations between moles and different types of representative particles such as atoms or molecules. In the next tutorial, we will investigate this concept a little bit further, and we will bring in the quantity of mass.